Hello guys, welcome to the video. So in this video, we are going to discuss our question, inverse of a number from left to right. Let's see our question. So in this question, in the input, we are given a number n. Also, there are some constraint. If the number is 5-digit long, if the number is 5-digit long, then it will contain all the digits from 1 to 5 till 1 to 5. Okay, and without repeating or missing any digit. For example, here if we are given 2 3 4 1 5, then all the digit will be from 1 to 5, okay, without missing or repeating any digit. And what is our task? Our task is to inverse the number, and let's see how inverse is defined. Inverse is defined as a number created by interchanging the face value from left to right, okay, and by reading from left to right, and we have to give first place to the left, the most left digit. We will understand our question. Okay, let's understand it better through open board. So let's suppose our n is equal to 2, 3, 4, 5, 1. So as you can see here, the constraint is valid that all the digits are from 1 to n, without repeating or missing any. So what will be its inverse? First, I will define its position, such how position is defined. So 2 will be our first position, 3 will be our second position, 4 will be our third, fourth and fifth. And now our task is to inverse it, right? To inverse it. So let's see what will happen in the inverse. So in the inverse, 1 will get to the 2th position. So 1 will get here, right? 2 will get to the 3rd position. So 2 will get here. 3 will get to the 4th position. 3 will get here, right? 4 will get to the 5th position. 4 will get here. 5 will get to the 1st position. 5 will get here. So that is inverse of our n that is given to us. Let's see more example. For example, we are given n is equal to 4, 2, 5, 1, 3 and 6. Okay, so here also, as you can see, the constraint has been passed that all the digits are from 1 to n without missing or repeating any. Now let's define the position 1, 2, 3, 4, 5, 6. Now it's our time to inverse it, right? What will happen in the inverse? Please understand it carefully. So the 1, that is our first position, this time 1 will get at the 4th position. So here. Now 2 will remain in the 2th position. 3 will get to the 5th position. So 3 will get here. 4 will get to the 1st position. 4 will get here. 5 will get to the 3rd position. So 5 will get here. And 6 will remain at the 6th position. So this is inverse of a number that is defined to us. Okay. Now I recommend you to try it yourself because you have already solved a similar question that was inverse of a number, and in that question the position were defined from right to left, but this time it is defined from the left to the right. Okay, so now let's discuss some important things that I think it is necessary for you to know. So if our number is 2, 3, 4, 5, 1, I want you to understand, if you don't know, that we can break this number. Example, 1 is in first place, so I can simply write 1. Okay, and 5th is in 10th place. So if I write 5 here with a 0, okay, and just keep it going. Just let's see. 4 it is in 100 position, so I will write 4 here and 100 and 0 0. 3 is in 1000 position, so 3 0 0 0, and 2 is in 10,000 position. So if I add this all, okay, then I will get my original number. Okay, so if you don't know, that's how we can break a number. So now that we know that, we are going to use a similar approach. Okay, so the first thing that should come in your mind, how you can place the position to the correct place, to the 5, for example 5 to the correct place. Okay, so okay, let's talk about something. So here we got 3, right? We got 3. And now if we want to place 3 in the 4th position, right? 4th position. So we have placed 3 here. So if I simply multiply 3 by 10, it will get to 30. And here it is at 10th position, right? So what we have to do? We have to think of something so that we can place our element to its inverse position. Okay. Now I want to tell you what we are gonna do. Okay. So first have some faith and see it. So I'll make 3 things here, 3 things that will be required to us. One is LD, that represent last digit. Okay. One is counter. Okay. We are gonna discuss about it. Just stay with me. And one is power. Okay. Now the number whose we will calculate inverse is, let's see, something, let's take 2 3 4 1 5. Okay, 2 3 4 1 5. Now our first step will be to calculate last digit, and we know we can calculate last digit just by using modulus operator, right? So our last digit will be 5. Don't ask why we are calculating last digit, you will get to know. Now what will be our counter? Our counter is initially, your counter is total number of digits. Total number of digits. So you must be realizing that we are required to calculate total number of digits. So yeah, that will be our first step. Now we have to calculate power. Why we are doing this? We are doing this to place our every digit in its correct position. Now counter will be initially what? Initially total number of digits, that is 5 in this case. Right? And position. So position, this is important. So here it is power. So power will be 10 raised to power what? 10 raised to power total digit. Wait. 10 raised to power, I can write here total digit minus last digit. Last digit. Okay, why we are doing this? We will get to know. Okay. Get some space here. Yeah. So let's calculate its power. So 10 raised to total number of digit, that is 5. 10 raised to 5 minus last digit minus 5. So if we multiply our counter by power, what we will get? We'll get just 5, right? We will get 5 because 10 raised to power 0 is 1. So here I will calculate it and write it total, whatever you get after multiplying. Now, this time our last digit is 4. No, it's 1. Our last digit is 1. Now I'm going to decrease my counter by 1. So this time we are thinking where we will place our 4. So 4 into 10 raised to power total number of digit minus last digit, that is 1. So if we multiply 4 by 10 raised to power 4, what will we get? We will get 4 and 4 zeros, of course. Perfect. Now our last digit will be 4 and my counter will decrease and it will get 3. So 3 into 10 raised to power 5 minus 4. So I'll get what? I'll get 10 raised to power 1. If I multiply 3 by 10, I'll get 30. Right. Okay, well, perfect. Now my last digit will get 3, and my counter will decrease and become 2. 2 into 10 raised to power 5 minus last digit, that is 3. So I get 10 raised to power 2, and if I multiply 10 raised to power by 2, I get 200. I'll write 200 here. Simple as that. Okay. Now we'll talk about the last digit again. That is 2. I'll decrease my counter by 1. into 10 raised to power 5 minus last digit. So we get 10 raised to power 3. So if I multiply it by my counter, it will be 1, 0, 0, 0. Okay. And now the important part. Now the important part that we are waiting for. If I calculate the total sum of it, what I will get? 5, 3, 2, 1 and 4. So what we calculated will be our inverse. As you can see here, the inverse for 2, 3, 1, 5 will be this. I mean, it is not mentioned here, but we will calculate it. So that's how we can calculate inverse. Okay. So now let's try to code it. It's simple. So the first thing was to calculate the total number of digits. So I'll calculate total number of digits. Okay, we are given n, so I'm going to create a temporary variable that is n so that we don't change n's value. And one more variable that is count, that is initially 0. While temp is greater than 0, we'll run our loop and we will keep reducing our temp. Temp equal to temp divided by 10. Right. And it will convert it into integer because it will give us a decimal value, and we will increase our count every time. Count plus equal to 1. Right. We calculate total number of digit. Now the next step. Okay. Now we are talking about this. So till when we will run our loop? So we will run our loop till while n is greater than 0. Eventually we are reducing n value, right, while calculating last digit. So while n is greater than 0, we will run our loop. Now what was our first step? Our first step will be to calculate last digit. So last digit equal to n modulus 10, and also I will reduce n, right, convert it into integer. Yeah, so we reduce 10. Now the important task. So as we discussed, we will be needing a counter. A counter is equal to total number of digit, right? So I will write counter here. That is equal to, here I will change my counter to total digit, that is TD, for better variable names always. Counter will be equal to total digit initially. Now, what I want to show you that we will be needing an answer so that I can add this all. We are adding all our numbers, right? So here I will take a variable answer that is initially 0. So how will I add this? Answer plus equal to what we are doing? We are multiplying counter, right? We are multiplying counter by the power that we calculated. So counter, create some space here, right? Counter multiply by power, let's calculate power, that is 10 raised to power total digit minus last digit. And then we will reduce the value of our counter by 1. Counter minus equal to 1. And whenever we get out of our loop, I will simply print my answer. Right. Now let's try running our code and see if this works or not. Accepted. Now let's try submitting it. Perfect. So this was our question. We first discussed what exactly is an inverse of a number left to right. Then we discussed a small formula or whatever you want to call it so that we can place our element to its correct position, right? And then when we added everything, we got our total inverse of a number. Also, what I want to show you, we missed it, that is it correct? 2, 3, 4, 1, 5 inverse. So here I will run it this time. 2, 3, 1, 4, 5. So let's see. It's inverse 3, 1, 2, 4, 5. So as you can see, we did it wrong. So I am depressed. What? 2, 3, 1, 2, 3, 4. Oh, sorry. 2, 3, 4, 1, 5. Let's calculate its inverse 2, 3, 1, 4, 5. Now let's try running it. 41235. So as you can see, it's similar to the answer that we got. So that's it for this question. If you liked this video, do not forget to like, comment and share. Thanks for watching.